All right, hey guys, looking at Lewis structures today, in particular talking about the octet rule and applying that with our drawing. So we'll start with a molecular formula, basically the collection of atoms that you see, and then I'll walk you through two separate examples where either we'll place the electron with the lowest electronegativity in the center, or we'll have to consult with a group number, and it's really simple to see the difference, but we just have to show. And so here, after you decide where your atoms are, you have to add all of your valence electrons. And so from there, you'll add 2 electrons for each bond that you'll draw. And then over time, the remaining valence electrons will have to go towards giving every atom an octet. Now, there are some exceptions to this, and I'll follow up with a separate video in order to talk about the exceptions, and also a couple of different things about what's called resonance and formal charge. So here for our first Lewis structure that we'll draw, we're looking at nitrogen trifluoride, where we have a collection of atoms. So if you have a scenario where you're following that you have a singular atom and then a separate entity with a number of atoms here, then you'll have to consult the periodic table to figure out which atom goes first. Now, using the periodic table, you'll have to figure out your group numbers, and those are the numbers that are on the top of each column, and they'll increase from left to right. Right? And so we say that the lowest group number will go in the middle here. So I have fluorine and I have nitrogen, and so the higher the group number, this is 18, this is group 18 over here in the noble gases. So I'll say 18, 17, 16, and 15. Well, nitrogen has a lower group number than fluorine, so we choose nitrogen for the middle. So I'll associate nitrogen in the middle, and I'll put my fluorines in a space around them. Now we have to add up all of the valence electrons, and again I asked you for homework to figure out the valence electrons and how they work. So simply we'll say that one nitrogen will contribute 5 valence electrons, and fluorine will contribute 7, but I also have 3 of them, for a total altogether of 26. Now, with these 26 electrons, the first things you will do is create bonds. So I will create bonds between these atoms in a sense that each bond is worth 2 electrons. So I just used up 6 electrons of my 26. Now I'm going to have 20 electrons left over. And finally, we need to make sure that all of these atoms have an octet. And so each fluorine right now has 2 electrons that are being shared and count for their octet. But we also need to give them 6 more in order for them to be satisfied. And we need to do that for all of the all of the fluorines that we see. Now I just used 18 electrons here in order for all of those to be satisfied, and 2 electrons are left over. I notice that I have 6 electrons that are contributing to nitrogen's octet, and in order to make that octet happen, I need to add those extra 2 electrons on the central atom. This in itself is your finished Lewis structure. And so you'll know it's complete when you've used all of your electrons, and you'll know it's complete when every atom that needs to have an octet will have an octet. Moving to a different example here. And so the striking example is that there's a couple of different atoms here, and we're not really quite sure which one should go in the middle. So if you see something like this, where there's a couple of different types of atoms, you need to consult your electronegativities. Now, we will put the atom that has the lowest electronegativity in the center. Now, for our interests, we are looking at sulfur, oxygen, and chlorine. Now, the lowest electronegativity here is sulfur, and therefore we're going to put sulfur in the middle of this diagram. So if you need to remember that, just remember the lowest electronegativity will go in the middle. Same deal as before. We need to add up all the valence electrons. So I know that sulfur contributes 6, I know that oxygen contributes 6, and I know that chlorine will contribute 7 twice. for a total of 14 plus 12, which is going to be 26 valence electrons. Now, in order to spread that out, we'll spread these to our bonds first. So 1, 2, 3, 4, 5, and 6. So I'll take away 6 valence electrons that I've just used for a total of 20. And now I'll start filling in all of the octets. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and we are going to be left with 2 electrons. Now we take those 2 electrons. Sulfur is needing an octet here, so we'll add those 2 electrons on the central atom. This would be your finished Lewis structure, and you can tell by all of the electrons being used up, and everything is satisfied by an octet.